Sigmatropic reactions. So here we have 1 3, 1 5, 1 7, 2 3 and 3 3 sigmatropic reactions. Okay, first we'll go for 1 3 sigmatropic reactions. So before going into this, we need to know what are the conditions for sigmatropic reactions, and what is the allowed conditions and what is the forbidden conditions. Those things we have to see in sigmatropic reactions. Here we can see here this is 1 3 sigmatropic, this is 1 1 2 3. So this is the migrating origin and this is the migrating terminus. Okay, the hydrogen goes from here to here, and now the what we get here, this one we get. So the first point what we need to remember here, there is no change in the number of sigma bonds and number of pi bonds in the starting product. So reactant and product, there is no change in the sigma and pi bonds. So this is the first point we need to remember. And then here both sigma bond and pi bond both are involved here. Okay, that is second point we need to remember. And what are the steps are involved here? So the first one is the C1 carbon bond is getting break. Sorry, C1 and H1, this bond is getting break, and there is a formation of a pi bond between a C1 and C2. Pi bond is forming, and there is a formation of a sigma bond between a C2 and C3. So these are the three conditions we have to remember, okay, about sigmatropic reactions. And what about the antifacial and suprafacial? Here when we are talking about electrocyclic reactions, there we spoke about the conrotation and disrotation. Okay, so when you are talking about sigmatropic reactions, here we need to talk about the suprafacial and antifacial. So what is the suprafacial and what is the antifacial? We'll see now. So suprafacial means when we have a allylic system like this. Okay, imagine that this is the filled place, and this is also filled, and this is the empty lobes. And now we have the sigma the hydrogen like this, the hydrogen which is moving from here. So imagine that, not hydrogen, sorry, we have a, okay, we take a hydrogen like this, okay, because hydrogen is s orbital, right? So this, imagine that this is the positive. Okay, and now positive means, here positive means we can take shaded region, and negative means unshaded, like this. Okay, so that means this is a positive, that means it has to be like this is positive and this is positive and this is negative and this is negative. Now this and this positive and negative can't this attack is forbidden, this is not possible. Okay, so now this will attacks to this positive attacks to this positive, so this is allowed, and this attack is called as antifacial. So why we call this one as antifacial, I will explain now. And imagine that in another case we have a positive charge here, and here also positive charge, and here also positive charge, and now this can attack to this and this can attack to this. See, this is called suprafacial attack. If hydrogen, if this hydrogen is attacking to the lower orbitals which is having positive charge, in that case this is suprafacial, and it's going all the way from here to here, upper orbital, that is antifacial. Just remember like that. Okay, I hope it's clear now, suprafacial and antifacial. Now we'll go for the 1 3 sigmatropic reactions in thermal conditions. So here we have see, in a allylic system, how many electrons are in, how many electrons we can take here. So this is 1 2, and this sigma bond also involving, right? So this is 3 and 4, so total 4 electrons comes, and 3 carbons are there. Because of that, it's 3 bonding or 3 molecular orbitals are possible, and that is psi 1, psi 2, psi 3. And since here sigma bond is involving, pi bond is involving, total 4 electrons, so the 4 electron we can fix like this. Okay, under thermal condition the HOMO is psi 2. Okay, and now we'll see for psi 2 what is the arrangement. Psi 2 means there should be C2 axis of symmetry. That means the shaded and unshaded region has to present in the opposite direction. So when you are talking about sigmatropic reactions, we just remember this way, positive and negative, so that will be easy actually. Now imagine that the here positive charge is there, means here C2 axis means here positive charge should be there, and then this is negative charge and this is negative charge. Okay, now we have a hydrogen here, positive charge. Okay, now this is allow because positive is allow, but here positive and negative is not allow. Okay, so from this kind of attack is called as suprafacial attack. So in case of 1,3 thermal condition, suprafacial is forbidden. Okay, now we'll see what is the interfacial. Okay, see this is allow. Now this has to go here. Okay, then only if this positive is going here, so this is allow. Okay, so this kind of is called as interfacial. Okay, and here in case of thermal condition, in case of 1,3 interfacial is allowed, suprafacial is forbidden. So next we have photochemical condition. Photochemical condition. Okay, now so thermal for 1,3 thermal is interfacial and photochemical will be suprafacial, because it will be just opposite only. Okay, so how in a photochemical it is a suprafacial? We have 3 molecular orbitals, psi 1, psi 2 and psi 3, and in excited state 1 electron goes from HOMO to LUMO. Okay, in case of thermal case, the HOMO orbital is psi 2 and LUMO orbital is psi 3, but in photochemical case both HOMO and LUMO is psi 3 only. This is you have to remember. Okay, now we have psi 3. Psi 3 is a HOMO here. Psi 3 means the arrangement will be, there should be some plane of symmetry. So plane of symmetry is possible when we have both the charges on the same side. Okay, so here we have a hydrogen plus orbital. So now this is allowed and this is also allowed. So this is called suprafacial attack. Okay, so this is clear. For 1,3 in thermal condition interfacial is allowed, in the photochemical condition suprafacial is allowed. And